Welcome to Martin's Institute of Teaching. This video is on signed binary numbers. It's part 4, and this one actually what we're going to be doing is practicing. So in the previous 3 videos I showed you how to work with binary numbers signed and unsigned. And here what I wanted to do is just to give you guys a chance to practice. So I went ahead and I made some problems for you guys that you guys can try. I'm going to show them to you right now. Then just go ahead, try to work them out. And then after you gave them a go, then go down there below and check and see how you did. So here are the problems. So here we have A. Well, here's what you're supposed to do. So it says consider the following 6 5-bit binary numbers. So in the first part what you're going to do is you're going to say, well, treating the numbers as unsigned, give their ordering from largest to smallest. Then after you do that, you're going to do basically the same thing again, only this time treating the numbers as signed, assume the 2's complement system, give their ordering from smallest to largest. So what you're going to do is the first time through is you're going to get these problems right here, and you're going to solve them. So you're going to find out what this value actually is. So you're going to work it out, figure out what the number is, put its number down next to it, do the same thing for all of them, treating them as unsigned the first time through. And then after you get their values, you're gonna put them down from A to F. And the first time through is you're gonna make it from the largest and then down to the smallest. Second time through is you're gonna treat these as if they are signed binary numbers, and you're gonna be using 2's complement. So after you do that, just figure out the value of each one, write it down next to it, and then you're gonna order them from smallest to largest. And I'll put the answer down at the bottom of this. So go ahead, if you want, pause the video now, try to and go and work out these different problems. So I'll give you a 5 count for you to pause the video, and then I'll assume that you've already gone ahead and started working on them. Okay, I assume that you paused the video. I'm going to go ahead and continue on now. So here's the first one, A. So treating this number as unsigned, what we're going to do here is we actually don't have to do any 2's complement on this because it's unsigned. So it means that this first value is included in the sum of the numbers. So converting this to the decimal, I know this first one stands for 1. Oops. So that's a 1 plus this is going to be a 2 plus that's going to be a 4. That's going to be an 8, and that's going to be 16. So it's 16 plus 8 is 24, plus 4 is 28, plus 2 is 30, plus 1 is equal to 31. So A is, or this value right here is equal to 31. So let's put 31 next to that one. So now we're going to treat the same number as if it was signed. So now the first value indicates that this is negative. So whenever we have a negative value, we have to use 2's complement and convert this number. So I'm going to go ahead and flip the value of all of these. So I'm going to get 0, 0, 0, 0, 0. Then I'm not going to forget to add plus 1, which turns this value to 0, 0, 0, 0, 1. And I know this is going to be nothing more than, this is equal to 1. Now, since this told me that it's a negative number to begin with, I know that this number up here is negative 1. So, I don't like how sloppy that looks. Sorry, I just don't like it. It's too sloppy, so this is signed. Okay, so that's A. So hopefully you got 31 unsigned and negative 1 signed. So let's go on to B now. So here's B, unsigned. So the first value is 0. Well, it's unsigned, so this is included in it. So let's go ahead and add this up. So 0 plus 2 and plus, so it's 0, no, this is 1, 2, 4, 8, so this is 8. So this value is 10. Unsigned is equal to 10. Now trying it as signed, well, we're going to look at this first value. Since here it tells you that it's positive, you don't have to use 2's complement, you don't have to convert it, you could just go ahead and consider it exactly the same as unsigned version. So this actually is 10. Don't have to do any conversions. So now let's go on to C. Here, this first value is going to be a 1, 2, 4, that's 8. 16. So this is 8, 24. This value is 25. Over here, this is signed. You know what? Before we go on to this, well, let me go back just for a quick second. So here, for this first one, for A, you notice that you have a 1 in every single position. When you have this, just count the number of places you have. So here I have 1, 2, 3, 4, 5. So if I do that, I say 2 raised to the 5 minus 1, and that should be equal to 31. The trick to this is whenever you have some number and they're all ones, it's really easy just to say, just count them, and the number of bits that you have, you just say 2 to the n minus 1 is going to be equal to the total of the addition of each one of these spots. So if you added these all up, you'll get 31. If you do 2 to the n minus 1, you're going to get 31 as well. So this is really convenient when you have a number with like 32 bits or something like that, or 64 bits, and you have to add them all up. And your professor says, okay, add every single one up. It's really convenient if you have every single bit is a 1. But if it doesn't have a 1, well, then it gets much less convenient. So, all right, just that quick tip. Now let's continue on. Okay, so let's see, we have not finished C. So, okay, we did the unsigned version, we got 25. Now we're doing the signed version. Again, this tells you it's a negative, so we have to convert this to, using 2's complement. So let's go ahead and flip everything. And then we're going to not forget to do plus 1 at the end. So we're going to get 0, 0, 1, 1, 1. And we know that this is going to be 1, 2, and 4. So this value right here is actually going to be equal to plus 7. But we know that the value we started with is a negative, so this value is actually going to be negative 7. Okay, so now let's continue on to part D. Okay, so here we have unsigned, so this is going to be 1, 0, so it's 1, 2, 4, 8, 16. So 1 plus 6 is just 17. Now we're dealing with signed. Now since this is signed, we have to convert it. So let's go ahead and convert it, flip everything. Let's not forget to do plus 1. We're going to end up with this value. So this is going to be equal to, this is 1 plus 2 plus 4 plus 8, so that's 12, 14, 15. So this value is equal to 15. But we started off with this. And since we know it's a negative, this is going to be equal to negative 15. Of course, we could, instead of actually adding these up like this, we could have just said, okay, there's 1, 2, 3, 4 spots. So we could have said 2 to the 4th power minus 1, and that'll give you a 15, because 2 to the 4 is 16, minus 1 is 15. So we could have used this shortcut method, which is nothing more than 2 to the n minus 1. Okay. Hopefully you got those. Let's go ahead and continue on with E. Here, this is a nice one because the unsigned and signed version will be exactly the same thing, because you have zeros in the front. A 0 in the front for the signed version tells you that it's positive. Here it doesn't matter because it's 0. So if we did that, we'd have that's a 0, 0. So this is 1, 2, this is 4 plus 8. So this value is going to be 12, because that's 8 plus 2 plus just zeros. And this will be the exact same thing. So E for unsigned and signed version is just 12. Now the last one, let's go ahead and do F. So this is going to be 0, 2, 4. So this is going to be 6, and these will be the exact same thing. And if we wrote these out, you'd say for the unsigned, from largest to the smallest, you would get A, C, D, E, B, and F. Oops. Now, if you did signed, from smallest to largest, you would get D, C, A, F, B, and E. So those are your solutions. So I hope you got those all right. If anything seems a bit confusing, and if you haven't seen the previous videos, I just recommend you go and review them one more time. But so I hope this really helped you out, and I hope you got them all right. So good luck in your classes, and we'll see you in the next video.